Ow. Oh. Okay, so I know I gave you. I know I gave you 195 as well to do, so let's see. Yeah. Okay, let's go 193 first, and then we'll come back. Then we'll do 195. Oh. Whoa, that's huge. Okay, so you will need your periodic table for this. We're going to turn to the second page, actually. Okay, now let's look at this. Keep an eye out for some of these polyatomics in this list. You need to be familiar with this list, so I would go through it several times just to be familiar with both the formulas and the names. So for example, KH or KCH3COO. Once you start getting more familiar, this is this part there. That's an acetate. That's a polyatomic. I recognize it right away. So it is potassium. How did I forget that I spelled potassium? I'm in a little bit of pain today, guys, so just be patient with me. Yeah, I know what I'm doing. Oh, frick. I think it's double. Okay, acetate. Potassium acetate. Next one, Ca in brackets, CH3, COO2. Again, recognize what this is. That's an acetate. It's a polyatomic. You just have to know it. So usually you'll have a metal followed by non-metal, like that, usually. That's easy to recognize that that's a non-metal. That's a metal, that's a metal. If a metal is followed by something that you find you're not familiar with, it's probably a polyatomic. Look it up, look the formula up to see whether it is or not. Now, this polyatomic takes the place of this, the non-metal. But notice how much longer it is, right? It's got a C, it's got H, got another C, it's got two O's. This is the only positive polyatomic, NH4. I would just memorize it so you know it right away. It's ammonium. And then followed by the P, which is slightly different. Notice the difference here. We got a P here. We got a PO4 here. PO4 is polyatomic. You would recognize that right away. The whole thing is a polyatomic. It acts like the nonmetal phosphide. It's got a -3 charge. Okay, so the name, same as the beginning before, ammonium. Phosphate. You have to recognize the difference. This one is a polyatomic. Phosphate, phosphide. Polyatomic. Polyatomics in general will end in H or ite. Okay, E, A, L, OH3, aluminum. That's easy to recognize. It's this part here that may throw you off. That's a common polyatomic, hydroxide. Again, it's acting like it's taking place of the nonmetal. This would be the nonmetal here. OH takes the place of the, in this case, the chloride, or something similar to a chloride, with a charge of -1. Okay, try to locate it just so you're familiar. Try to locate phosphate and hydroxide in the table so you know where it is. See if you can do that now. Okay, you know where that is now. Okay, next one. This, keep in mind, is multivalent. So this is a little hard. Ooh, voice cracked. Don't laugh. Bad day today. Okay. So we'll just write down part of the name. We'll put a space in the middle. Iron something. Same as what I just did before. Hydroxide is this thing here. That's hydroxide. Okay. So what goes in the middle? Reverse the crisscross. So put the 3 there. The 1 goes here. You get Fe plus 3 OH minus 1. This is correct. So you don't have to multiply by a correction factor. The hydroxide charge is -1, so this must be +3. This is a 3 here. Does that make sense? Okay. G. So C2CrO4. So this takes the place of a nonmetal. It's a polyatomic. You can look what that is. It's chromate. So this becomes, whoa. Potassium chromate. Next one, similar, Cr2O7. That's dichromate. This is a 7 here. So, talk about lazy. Watch this. Does this work? Mr. C, you're so lazy. Yeah, today's a lazy day. Put a di in front. Potassium dichromate. That's your dichromate here. Di meaning 2. So there's 2 chromium as opposed to 1 here. I, calcium, hydrogen carbonate. So you can use bicarbonate or hydrogen carbonate. So it's calcium. You can write bicarbonate. That's the shorter way. Or hydrogen carbonate. Either one is fine. So look at this, by the way, on a side note here. We have a 2 there. Why is that? Why do we need brackets? Because there's, in each of these cases, look at, there's no brackets here. Why? Because there's only one of them. Here, we need brackets because there's 2 of them. Okay, here we needed brackets. There's 3 of them. If there's 2 or more, you need brackets in the formula. 3 of them, brackets needed. Okay, no brackets needed here. How come? There's only 1 phosphate. Why are the brackets needed? There's 3 ammonium. Same thing here, 3 ammonium. Why brackets here? There's 2 acetates. Why no brackets here? There's only 1 acetate. Okay, last one. Magnesium phosphate. In the middle. Yes, no? We need something here? No, I don't, because magnesium is not multivalent. What does that mean? Multivalent means, or to be not multivalent means it only has 1 charge. If you look at it, magnesium has a +2 charge. Okay. Number 2, you're supposed to complete it. So let's go through this together. Permanganate. Again, notice what all, in number 2, notice what all these words, these names have in common. They all end in -ate for the most part. I think there's a couple of exceptions like hydroxide, cyanide. Those don't, but most of the others do, which means they're polyatomics. For the ones that don't end in -ate, hydroxide, you just have to know it's a polyatomic. Cyanide is a polyatomic. Just have to know that. Okay. Permanganate. MnO4. So you have potassium +1. Permanganate, MnO4. Make sure you get the charge right. It is -1. You just write down the symbols. If the charge, the units are the same, 1 and 1, just write down the symbols, KMnO4. That's it. That's your formula. Sodium chromate. Sodium is +1. Chromate is -2. Now you got to crisscross. You get Na2, CrO4. Why no brackets? Because there's only one chromate. C, ammonium nitrate. Ammonium is the only positive polyatomic. Nitrate is NO3 minus 1. Same unit for charge, 1 and 1. Just write down the symbols. NH4, NO3. No crisscross needed. D, lithium. Lithium hydroxide. Again, same units of charge, 1 and 1. Just write down the formulas. Aluminum hydroxide, Al plus 3. Hydroxide, look it up, minus 1. Hydroxide is one you should memorize. It's one of those well-used polyatomics that ends in IDE. Crisscross. So you're going to put the 3 here. 3 is going to go over in that corner. So you get Al. 1 crosses over to give you 1 Al. And 3 hydroxide. Is that right? What do I need? Good, because there's more than 1. 2 or more, you need brackets. F, lead 2 perchlorate. Lead gives you the charge. You don't have to look it up. Perchlorate, ClO4 minus 1. Crisscross, PbClO4. And yeah, same thing. The polyatomics is there's more than 1. 2 or more, you need brackets. G. Hydrogen sulfide, you can look that one up. Hydrogen sulfide is HS. Minus 1. FeHS 3. K2 CR2O7. What am I? Sorry. See, I just lapsed there, right? But pain's getting to me. Vanadium V. Whoa. V means 5. Nitrate NO3 minus 1. Crisscross V NO3 5. I, magnesium acetate, Mg plus 2. Acetate is CH3COO minus 1. Crisscross. Whoa, let's do that. And then F. It's J, I mean. IJ. Only macro. I need sleep too. Okay. 10-2. Okay, this is one I would pay attention to. Cyanide is a polyatomic, believe it or not. When you crisscross, you get S and C and brackets 2. Okay, so cyanide is one of those polyatomics that ends in IDE. Most of them will end in ATE or ITE. We'll go on to 95 or 195 in a second. Go ahead. Yep. Since I need a little break, You take a little 2-minute break. Ow. Ignore me for 2 minutes. By the way, you get pretty good on the test overall on average. Pretty good. Yeah, I'd have them for you, but like I said, I couldn't even bend down to pick up the file. Oh well. Sure, how was it? Okay?
It was okay. The core model's kind of good.
Yeah, they're harder. I would have, yeah. It was harder. Oh, gosh. Okay. Let's go over page 195. I'll do this orally. Well, I'll go over the tougher ones with you if you need it. But I think really what you need to realize is you've got the prefixes. You'll be given the prefixes. Having said that, girls, I would become familiar with them. Okay, so some of them you already know. Mono, meaning one. Di, we talked about that already. Two. Tree, three. Tricycle, tri. Four, Tetris, four-sided. Five, pentagon, five-sided. Six, hex. I place a hex. Okay, so let's look on the five. For example, the first is two votes. So you when you name it, you name it. dinitrous oxide. One other, you do not need mono. You never use mono in front. You can skip mono when it's in front. Okay, for example, the next one, it's not mono carbon dioxide, it's just carbon dioxide. Thanks. Oh, right there. Thanks. Next one. It's not monophosphorus, just phosphorus triiodide. And yes, there's two I's. It's a little confusing. Tri, one word, but it's Tri, and then iodide, I-O-D-I-D-E. Is it making sense? Guys at the back, we're focusing on what you're reading off. I'm assuming you're reading off. I don't have time to check today, guys. I'm just trusting you. Cl5, phosphorus, and then 5 is E sulfur. It's not monosulfur, it's just sulfur dioxide. Drop the mono in front. F, dinitrogen tetraoxide. G, tetraphosphorus decasulfide. And I think you're picking up on one other rule, and that is they all end in IDE. It's just like a two-element ionic compound. Same rule for that as far as the ending. Change the ending to IDE. For any two-element compound, change the ending to IDE. Okay, so H, disulfur decafluoride. I, nitrogen triiodide. J, you tell me if this is right or not. Nitrogen oxide. What's missing? Yeah, you do need a mono in the middle if it fits, yeah. So nitrogen monoxide. That's a pollutant, by the way. So the pollutants here are nitrogen monoxide, sulfur dioxide, carbon dioxide. Those are expelled from your exhaust in a tailpipe of a car. 2, write the formulas of the following compounds. Nitrogen tribromide, so it's NBr3. Yeah. Oh, I knew that. I was just testing you. Do 2 right now. If Mr. Keonyar falls over again, just ignore him. Keep working. Do number 2 as well. Give it a try quickly. Shouldn't take you more than 5 minutes. So make sure you have your, by the way, your workbook here next class. I'll assign a few things from it for sure. I could start today, but I think I'll just do the worksheet.
This one's like, I messed up a few times, so it's kind of small.
Yeah, just put it here. Thank I don't have them here, but
Like,
just a file folder is what I want. Okay, number 2, nitrogen tribromide, NBr3. Next one. Texas. No one's heard of that? Hex spell. I place a bad spell on you. Okay, no one cares. Okay, fine. I thought it was good. Helps me. C, dinitrogen. N2 tetra means 4, so N2S4. D, OF2. That help you? No? Okay. F, sulfur trioxide, SO3. G, phos. Uh, Cl2O. J xenon is Xe and then F6. Okay, so you can work on, whoa. Give me a second. I can't preview the page yet. I think it's page 199. Do you have a page 199? Can you see it? 199. Okay, sorry, 201. Page 201. You can start on that. Just work on the whole thing. Start on that in class. Whatever you don't finish is for homework. So page 201. Yeah. Yeah. Normally I do more with you, but I think I'm in a little pain. So work on that. And then whatever you don't finish, it'll be for homework. Thanks. Say it again. Oh, explain the following terms related to chemical naming. Yeah, multivalent in terms of chemical naming. And when you're naming it, you're gonna have to, if it's multivalent, you have to include a number in it when you name it. So, for example, iron 3 hydroxide, right? So you have to, when you name it, include a number in the middle. That's because it's multivalent. Fe is multivalent. Polyatomic, you got to look up the name of the polyatomic, right? It's probably going to end in ate or ite. And ratio of the ions, when you're now, how does that relate to the naming of it? That might, yeah, that doesn't really relate to the naming of it. So just maybe write down what it means. Ratio of the ions. That's good enough.